Now we will study about the free particle in continuous state. I have already explained about the general shape of the particle, and this is the simplest one-dimensional problem, and it corresponds to potential energy, which is approaches to zero. That is, we can say that v of x equal to zero for any value of x. And in this case, we can write Schrodinger equation. First, I will write basic equation. uh, First, I will write the basic Schrodinger equation, which is equal to this is about the free particle particle in continuous state. Now, first, I will write the formula, that is minus h cross square upon 2 n delta square upon delta x square psi of x plus v of x equal to e of psi of x. Again, here also we can write into psi of x. Okay. Therefore, we can write here minus h cross square upon 2n delta square upon delta x square plus v of x of psi of x equal to v of, and we can write here equation number. Okay, but in this case, in this one-dimensional problem, which corresponds to v of x equal to this equation number, but v of x equal to, and therefore equation one becomes we can rewrite in equation one, that is minus x square upon 2n delta square upon delta x square psi of x equal to e psi of x. Okay, that is equation number two. Because v of x equal to 0, and therefore equation number 1 becomes equation number 3, where we can say that v of x equal to 0. Now, is now we can rewrite the initial equation was h cross square upon 2n delta square upon delta x square psi of x equal to e psi of x. Equation 3 can be written as minus h cross square upon 2n delta square upon delta x square psi of x minus e equal to 0. Taking psi of x common, we can write minus x cross square upon 2n delta square upon delta x square minus e in bracket equal to 0. Again, we can write h cross square upon 2n delta square upon delta x square plus e psi of x square. This is equation number 2. Okay. Now, equation 4 can be written as we can multiplying minus 1 to LHS as well as RHS. We can write h cross square upon 2n delta square upon delta x square plus e psi of x equal to 0. Okay, that is equation number. Again, this equation we can write as multiplying or taking h cross square common from both sides to m. We can write delta square upon delta x square plus 2me upon h cross square, because there is no term of uh, h cross square upon 2m with e. Therefore, we can rearrange it like this of psi is equal to 8. And therefore, multiplying or um, dividing by h cross square upon 2m to LHS and RHS, we can write delta square upon delta x square plus 2me upon h cross square psi of x equal to 0. Question number 6. Then equation 6 in terms of k, where k is a wave number, we can write delta square upon delta x square plus k square psi of x equal to 0. And where k is, where k square equation from equation 6 and 7, we can write k square equal to 2me upon h cross, which is implies that k equal to root of 2me upon h cross. Okay? And where k is given. Okay? And therefore, we can from this equation 1, from this we can write general solution of equation 1. We can write with usage. Therefore, basic equation is minus h cross square upon 2n delta square upon delta x square psi of x equal to e psi of x. From this we can write square from this is from this we can write delta square upon delta square plus k square into psi of x equal to 0. And from that we can write h square equal to 2me upon h cross square, which implies that k equal to root of 2me upon h cross. Okay, here k is variable. Okay. And the most general solution of this is a combination of two linearly independent plane waves, that is psi of x plus equal to e raised to ikx, is variable, and psi minus is equal to e raised to minus ikx. Okay, and therefore we can write general solution is equal to psi k of x equal to a plus e raised to ikx plus a minus e raised to ikx. Okay, this is our next number. We will write next equation is equation called 7. Then we can write this is equation number 8. This is equation number 9, 10, and 11. Okay, and therefore psi k of x equal to a plus e raised to ikx plus a minus e raised to minus ikx. And where a plus and a minus are two arbitrary constants, and therefore complete wave function is thus given by the stationary state, and therefore equation 11 can be written as, I will rewrite equation 11. Equation 11 equation 11 is phi k of x equal to a plus b is to phi k x plus a minus b is to mu. Okay, this is your equation number 11. Therefore, equation where I have already explained about the a plus and a minus are two arbitrary constants, and therefore complete equation we can write in terms of omega, where omega is equal to e upon h plus. But we have e. What is the e? E equal to in terms of omega, or we can write in terms of omega as well as in terms of h plus. And in terms of omega, uh, we can write e equal to h cross. Again, we know that the value e for energy, and in terms of energy, we e equal to h cross square k square upon k, and therefore we will write here equation 11 in terms of omega. We will write psi t of s from t equal to a plus e raised to I kx minus n, okay, plus a minus e raised to minus I kx. Here instead of minus we can write plus n. Okay? And therefore, but omega is equal to e upon x plus. Omega equal to e upon x. We will put here like this. Again, I will divide into this one. Omega equal to e upon x, which is equal to e upon x cross equal to h cross k square. Okay. I already explained about the value of k square in previous session. That is equal to, in terms of energy, that is k square equal to 2me upon h cross. Okay, and here we can write, this implies that e equal to k square h cross square upon 2m. We have omega equal to e upon h cross, but what is the e? H square h cross square upon 2m into e upon h cross can be written as e into 1 by h. Therefore, this h cross square, h cross 1 h cross is cancelled, and we can write omega equal to h cross h square upon 2. Okay, and therefore we will put omega equal to h cross h square upon 2m in equation. Here I'll write equation number 12. Okay, and therefore equation 12 can be written as a plus e raised to I kx minus omega of omega h cross k square upon 2m into plus a minus e minus I kx plus again omega h cross k square upon 2m into. Okay, and this is your equation number. Okay, and therefore this is your psi of k that's one x comma. Okay, and for the in this first term, what is the first term? That is the this can be written as psi k of x comma k is equal to psi plus x comma plus plus psi minus x comma. And therefore, we can say that psi plus this is first term, which is equal to, we can write psi plus x comma p, which is first term. This is a plus a plus, comparing 13 and 14, we can write a plus e raised to I ax minus n, or you can write minus 8 cross a square upon 2n. This is the first term, which represents wave traveling to the right. Right. And psi minus is the second term, psi minus x comma p. It can a minus e raised to minus r ax minus x plus h cross a square upon 2n, which keeps traveling. There is a represents a wave traveling to left. Okay? And the intensity of these wave functions can be written as a plus bracket square and a minus bracket square. Okay, and therefore we can find out the uh, wave velocity. Next point is, therefore we can, from equation 13 or 14, we can write intensity of this wave. Intensity of this wave given by a plus square and a minus. Okay, and therefore we have the speed of the waves, plane wave, is given by psi plus minus x. It is equal to, this implies that p wave equal to omega upon t. But what is the omega? Omega equal to e by h cross upon t. This can be written e upon h cross. But what is the e? E can be written as h cross square k square upon 4n upon h cross t. This can be written as h cross square k square upon 2n into 1 upon h cross t. This is equal to, when expression cancel, h cross k upon, okay, this is your equation number 16. Okay, and therefore, but V classical, what is the V classical? V classical equal to P upon N. P means momentum. Momentum equal to H cross P upon N. Therefore, multiplying and divided by 2, we can write H cross K upon N. But this represents equation number 15, which is V wave. Therefore, 2 times V. Therefore, we can say that V classical is twice as fast as that represent function, and therefore the wave function is not normalized, and therefore we can say that it tends to infinity.